interview, he was so like enthusiastic about it too, and he really explained so many things that I had that I had no idea about.
Vince, and this actually is the bridge already to myself. So I used to be responsible within the Siemens is a big company.
Yes.
And within Siemens we have various divisions, and basically or very simply you can split them into two kinds. You have on one hand you have the supplier side when we look at the industrial market. Okay.
Yeah.
So there is, for example, the digital factory. That's what they're called, digital factory. The digital factory division, which supplies mainly to all kinds of machine builders and all kinds of verticals, aerospace, automotive, and so on. And within the DS, we have a competence center for additive manufacturing. And this competence center, I was responsible for the product management and in my former role, I was responsible for the product management and the sales. I was leading that. And since this was a matrix organization, I also worked very closely with Vince and Andreas Starr and Dave Madeley and all these guys, since they are in their business unit. So this is one division, as one segment below. In their business unit, are responsible for the PLM chain, PLM ecosystem. Yeah. So CAD, CAE, CAM.
Right.
And now, this is how big organizations or companies like Siemens actually work. I'm now transferred beginning of this year to our energy division. So coming from this user perspective, I'm from the supplier perspective. I now am actually implementing 3D printing.
That's
so yeah.
That's very interesting, actually.
So I can bring together both roles, and in my current assignment, we are bringing 3D printing or additive manufacturing to the turbine.
Yeah,
that's how simple you can put it.
Absolutely, I have two questions for that. One is I had a chance and I reported on that very important case study that Siemens published on the turbines that were the turbine blades that were produced by ALM. Was that under your supervision already? And the other question that I have is I did a report, but this was like 2 years ago. Actually, I didn't do the report, but I worked on it. We did a report in Smart Tech, and which is the company that I work as an analyst for. And the funny thing is on the energy sector, and what emerged from the energy sector is that there are so many possible applications, but nothing had been done. Like really, like energy companies invested like nothing over the past like so many years on this. Do you confirm this, or is this my?
No, I can't support this thesis. So to say that this was already under my first of all, this is not the way I work.
Right.
So we are all colleagues and we work together. So. Yeah. And it would be completely wrong and absolutely, how do you say, unverschämt in German. Are you Dutch?
No, I'm actually Italian.
Oh, okay. So it would be, I don't know the Latin word for it, but it would be, we're completely wrong. The guys have been working on this for years.
Right.
And now they went live. So
of course.
It was the blade you were probably talking about that our CEO, Joe Kesa, also showed at the analyst conference, was produced in Worcester, in England, by Material Solutions.
Okay.
So, and that is a Siemens company.
Okay.
So they are fully owned by Siemens.
And they are a Siemens company, but they are an additive manufacturing service, basically.
Yeah.
Okay.
Well, what we do is we differentiate very clearly. Or we see additive manufacturing as a main lever, and we differentiate very clearly on the amount of IP that is in the parts. So if we believe that a part is a very high IP, we only produce this in-house.
Uh-huh.
So therefore we have We have a couple of, and this is also public. So
Right.
we have a production hub in Finspång in Sweden,
Okay.
and we also have another production hub, for example, in Worcester Material Solutions, which is
Okay, which
a
is
Siemens
internal,
company.
and they of course use SLM.
Yeah, no, but we have two. So we go two, and from there we go actually into two. It's always good to stand on 2 feet. So on one hand, we do our internal production, for example, there, but they are also open to third-party business. So we also do service business. Yeah.
Of course. Oh, okay. So I understand.
So if any aerospace, automotive, whoever customer comes up and wants to have a part printed, then we can do so.
Right. Of course. And so, so what was your role before as the product manager for the additive manufacturing part of the digital factory? I mean, what was your role then? And so, what is it now exactly?
Okay, basically it's very simple. Back then, we were aligning the entire digital factory portfolio roadmap. So starting off with the software, CAD/CAM CAE, mainly NX, then also the SCADA system and the MES.
Yeah.
Down to the controllers and the IOs, so the hardware on the machine. So the CPUs, the CNCs, the HMIs, the IOs. We were bringing that into mainly. We were focusing on the fusion, direct energy deposition,
right, okay.
material jetting, and FDM.
Okay.
Yeah, those were our. And then we had we signed up, or we got into partnerships with our with machine builders. So
right.
That's actually it's all public. Also, we are partnering with EOS.
Yeah.
We're partnering with Trumpf.
Yeah.
We're partnering with DMG. We're partnering with Stratasys, and we are also partnering with HP.
Okay.
So working together very closely with Stratasys. Yeah.
Yes, I followed most of those, all of those actually, when they were announced.
Yeah. So, and that was, since there's not only EOS and Trumpf out there, those were more or less also the 4 technologies we were focusing on.
Right.
And then our target was to sell these portfolio elements to the AM market, mainly. But not only the machine builders.
Of course.
Because this is where the revenue comes from, right?
Absolutely. From you mean the sale of the machines?
Yeah, I mean, it's very simple. An aerospace or aviation customer or production unit, let's take a European one, Airbus,
right?
Will buy a machine, but they will not buy CPUs and build their own machine. So let's say they are an important part of the game,
right?
But the machine itself is equipped by the OEM. Right.
Of course.
So that's why we were focusing on
Absolutely.
Very simple always.
Absolutely.
Yeah. So and now.
Yep.
Now that I transferred to the energy sector, I am responsible for driving additive manufacturing into our large turbine, so gas and steam turbine, all the big stuff. Driving additive manufacturing into these applications on the service side.
Okay, so just to understand, you would be producing. You would also be producing parts for customers that operate in the energy infrastructure business.
Yes. So through Material Solutions, precisely through Material Solutions, this unit Material Solutions, if our competitors would approach us and would ask us to print parts for them, we would do so. Why not?
Okay. Yeah. So,
The question is if they want to give us the data, but that's
right.
that's a different topic.
Yeah, there are just so many, right?
No, but we also produce. I mean, we produce for the car industry or the automotive. We
Right.
produce for the medical sector. We produce for Formula One car, and we also would produce for. I mean, let's name it. We would produce for GE. GE is working with MX, for example. So why shouldn't we deliver to them anyway?
Right. Of course. Of course. So, of course, I guess you're seeing a lot of growth in the adoption of additive manufacturing. Oh, that's one question. One of your focus, I read some, was the industrialization of this process, obviously. So putting making additive manufacturing fit into a more industrialized and automated process flow. So, and that is exactly when I talk to aerospace manufacturers, they say that's the biggest limit right now. What are you doing to that end, and what needs to be done, now?
Well, I think that we have to split it up into what can be done short and what can be mid and what can be long term. I'm fully enthusiastic about the technology. Okay, it's great stuff. But on the other hand, and it's fantastic the topologies and geometries
Right.
and also the materials that are now actually feasible of being put into physical parts. So it's pretty cool stuff. And finally, we can actually take the next step into really optimization on all levels. But the problem at the same time, and it is an issue, is that the machines themselves, the processes are not very stable.
Right.
So now we can say, well, it's additive and it's a physical-chemical process which has been done on the machine. So it's not as simple as milling.
Right.
Correct. That's right.
Right, of course.
But let me put it this way. Injection molding is also a physical-chemical
Exactly.
process.
Yeah.
And I think the right first time percentage and the KPI of that for injection molding compared to additive manufacturing is quite higher.
Yeah.
So now one can say, well, injection molding is only some kind of material at some kind of temperature with some kind of pressure shot into some kind of a form.
Yeah.
Well, then additive manufacturing, if it's that way, if it's all that simple, then additive manufacturing is only, if it's powered fusion, then additive manufacturing is only a laser moving over some kind of a metal material and welding it together.
Yeah.
Where's the problem?
Exactly.
And when we look into these processes, that's the process, right? And so now we can either have a powder bed or we can distribute the powder to the focal point. Well, then we call it DED or we call it powder bed fusion. But overall, the machines themselves are far from closed loop. Yes, there's a lot of basic research to be done before we can get to this closed loop. And it's a little bit like the Holy Grail. Nobody has found it.
Right.
What is the closed loop, and how do these very simple, in brackets, how do all these variables actually correlate?
Right.
What's the algorithm behind it? And how does this apply to plastics? We're not so interested in plastics because we want to really go for turbine parts, so we need metals and we need really high-end metals. But when we look at the machine from a let's say start off with from a production machine environment, and I think they're not so much machine tools, they're more production machines. They are far from a filling station, a filling application I can buy in the market today, and they can tell me precisely which pressure and which amount and is in which bottle where, when.
Right.
And this traceability and trackability of the parts is not in the material throughout production, is not given today. So I think that's a little bit long term. And on the other hand, there are very, very short term things that can be solved. and it gets also we are touching on EHS matters. And I think the first thing that we have to actually consider when we build parts is the safety of the people involved.
Sure.
And when we look at the production today, the material is unhealthy.
Right.
As simple as that. And we have also done some research on the contamination of the workers on the machine, or at the machine over the week, and it's disastrous.
Oh wow!
Simple as that.
Yeah.
So it's official. We put it out. You can read it up.
Is this related to the UL study that just came out, or is it separate? It's something you did.
Study. Yeah, it's our own study.
That would be very interesting. If you could send me a link when you get a chance, that would be very interesting. Yeah.
Yeah. Wait. We'll do that right now. Please. Everything we do now, we have done. So let me see. Okay, I have to.
Health and safety has emerged recently. We actually did a couple of articles a few months ago on the subject. One of our journalists covered it, and there's it's definitely something that is a topic that's been discussed right now. And also, what you were saying about the powder, the process, injection molding, and the laser melting process being, chemical and, having a chemical change as the process happens. One thing that, in a way, like additive manufacturing has more control than injection molding on what is going on in the powder.
Yeah.
Because
so let's put it this way. So if we have a system today, in some kind of a monitoring system in place today, and this monitoring system detects that one layer is incorrect, why is it not? So what is the conclusion from that? And this is where additive manufacturing has taken the first step by analyzing.
Yep.
But they have not come to a closed loop control, which would then mean, okay, what does this mean? What is the solution to this?
Right. But in the injection molding, you couldn't even analyze it. So people didn't even. Maybe you didn't even realize that there would be an issue.
But,
so, all right.
And then let me see. Okay, here I'll send you the link.
Please.
Okay, let me see. Where's here? Where did I put your?
You can also send it. Oh no, because I called you on Skype, but actually we're not. We're on the phone.
We're not on Skype.
Right, I'm actually on Skype.
So here we go. Email at Apple, David Shear, right?
Yes.
So there you go. It's without flowers and without kisses, so...
Okay, yeah, just a link is fine. Thank you.
Okay, so that's what we done, and it's published, and it's available. So.
Fantastic. Yeah, I mean, honestly, but I have plenty of information for this interview. I'm gonna try to kind of, I recorded the interview, so I'm gonna now re-elaborate it, and I can send it to you to view if you want. It will come out on my website, and on the and in 3D Stream we'll also be using it to I guess promote a little bit the conference, and we will meet again at the conference.
Yeah, But please send it to me so that I can pass it through also my press department. Okay?
Yes, absolutely.
So
I
please
will.
do not publish it before I have not.
Yeah, no,
Okay.
I want, because also there were a lot of concepts that are quite complicated to explain. So definitely would want to make sure that everything is correct.
Yeah, that's correct. Otherwise, we have more work afterwards than
Right.
if we publish it right in first place. Okay.
Definitely.
Cool.
Okay. Thank you.
And we haven't even started talking about the turbines.
Oh, please,
But,
actually, honestly, that would be great if you want to just mention it. Explain to me a little bit on that.
Yeah, the last thing I actually want to really comment on is that I do not agree that.
Right. Yeah.
Let's see. When you put it this way, and I can actually find something on this.
Right. Okay.
Let me see.
Well, that the energy industry had not really considered additive manufacturing in the past.
No, it's. You stated that we had not, or that the energy sector has not picked up on additive manufacturing, and you referred to 2 years ago.
Yes, up until 2 years ago. Yeah.
We actually, and I can really put it this way. I think that's what I said.
To be honest, I meant the oil and gas industry, but it's probably what you mean.
I will find it.
I did find a few cases of prototyping, I think, but not really not much research being done toward production. But that's probably because I was just not aware of it.
My former, I'll find it.
Sure.
We published is one of our corporate core technologies.
Mm-hmm.
We believe that we have a very good idea and a very good plan, and also have very good applications that we are working on. And we're going to enhance our activities.
That's great. Yeah.